Electrons are arranged in energy levels or shells around the nucleus of an atom. The actual orbit shapes are a bit too complicated to cover in such a short lesson, but on average, the orbital radius increases as the energy levels increase. In our diagrams, the shell nearest the nucleus is going to represent the lowest energy level or shell, and we draw a circle to depict each shell. We use a dot or a cross to represent each electron, and we'll represent the nucleus by the chemical symbol. Each electron in an atom is in a particular shell, and the electrons must occupy the lowest available shell nearest the nucleus. So, when we are drawing the electron configuration, we have to fill up each shell in turn, starting with the lowest. We'll take a lithium atom as an example. With an atomic number of 3, it must have 3 electrons to balance the positive charge of the 3 protons in the nucleus. It's worth remembering that the atomic number tells you the total number of electrons in a neutral atom. So, we put the first electron into the first shell, and the second. However, this shell can only contain a maximum of 2 electrons. That's one of the rules that you need to remember. The third electron, therefore, must go into the next shell, which we draw as a larger circle around the outside of the first. And that completes the electronic configuration of a lithium atom. The same process of filling up shells applies to larger atoms. You always start with the lowest available shell, and whenever a shell is full, the next electron to be added goes into the next shell. And that's pretty much it. All you need to know is how many electrons can occupy each shell, and at this level, you only need to know the rules for the first 20 elements. The maximum numbers are as follows. The first shell can contain a maximum of 2 electrons. The second shell, up to 8 electrons. The third shell also has a maximum of 8 electrons. And the 19th and 20th electrons go into the fourth shell. And this would actually represent a calcium atom. Note that as we fill up each level, we've been drawing the electrons evenly spaced out on each shell. This is to keep the diagrams tidy and make it easier to count the electrons. And what's more, there's a shorthand way of writing this down. 2, 8, 8, 2. The first number represents the inner shell or lowest energy level. The full stop shows how the electrons are separated between the shells. The second number tells us how many electrons are in the next shell, followed by the third and fourth shells. And so now it's your turn. I'd like you to draw the electron configuration of a carbon atom. Pause the video, find a piece of paper and have a go. And here is what it should look like. It has a full first shell and 4 electrons in the outer shell. Did you get it right? Now, how would you write the electron configuration in numbers for this atom? Pause the video again or rewind if you need to have a think about this. The answer is that it would be written 2.4. And now that you have covered the basics of drawing electron configuration,